Okay, well, here we are a little bit more than halfway through the semester. Make sure. And it's good to see you all. This is what week 10, but we're in module 10 anyway. All right. So the first thing I'd like to address, and I know you're all curious, and there was a question about, why do we have assignments in the midterm? Well, that's kind of the way it panned out because of all the breaks each Monday and holiday. I tried to plan it accordingly, but yeah, the course is kind of backloaded more as far as the amount of work. So I'll apologize up front, but you'll be tasked to do a little bit more for the rest of the time we're together than you did in the beginning of the semester. So please stand by. All right. So with that being said, you do have a midterm this week. And I will review a couple things after going through module 10. I do want to remind you that module 10 is not a part of the midterm. The midterm will cover modules 1 through 9 with, it's only 8 modules because module 8 is the spring break module. So technically it is generally, for the most part, half of the course. So this is the way that the midterm will work. Please make sure you go through the midterm module, and I will, let me bring this over. Make sure I got everyone that's here. So if you go into Canvas, there's a midterm exam module. And you all see that. And then within that module, there's a study guide. It's just a document that I put together that highlights some of the main points that are covered in the midterm. Just read through this, take notes. You can use these notes. They have to be physical notes. So if you can, or if you have the capabilities, I would print this out and write on it so that you understand. And I will review this after I finish the module 10. I know that, but I wanted to point it out first. So that's the study guide for the midterm. And then another key aspect, I need for you all to go through the testing responders lockdown browser part of the module. And it's basically, it provides the guidelines for downloading the browser. It's a really quick download. And then testing it by answering 3 simple questions. I think they're mostly simple, but it's not anything heavy. I'm mostly concerned about ensuring that everyone has downloaded the browser. So you get 3 points no matter whether you answer the questions right or wrong. And there's a few, actually, I won't tell you, but one of these, or even maybe 2 of these, are on the midterm. So that's one of the reasons to do the responders lockdown browser test. So that's an additional item in that module. Let me go back to the module view so everyone is aware. Midterm exam. Right up to module 9. So the study guide, responders lockdown browser, and then here are basically the parameters, or essentially the definition of when the exam opens and closes, and I'll highlight that again on the slide. And yes, it's once you click into the midterm, it does require that you have the lockdown browser loaded or download it, because once you go into the exam, basically it will launch lockdown browser, which means that basically it locks down all of your, any additional monitors, any additional applications. You cannot run them on the system that you're taking the exam. All right, so to highlight the kind of the parameters around the exam, it opens Wednesday this week at 8 a.m. and it will close Friday this week at midnight. Now, the exam duration is 90 minutes. That means that once you open the exam, you have 90 minutes to complete it. Make sure I get the attendance. All right, so 90 minutes. It's not a cumulative or save your spot or anything like that. It's basically open it, 90 minutes to complete. There are 50 questions. So if you do the math, it's slightly less than 2 minutes per question. And most, if not all, and we'll review that quickly here. I think probably most of the questions are multiple choice anyway. And I know it would probably be easier to test some of those queries inside of the developer. Well, yeah, I was thinking about that, and maybe I may change that. But the college requires that we use the respondents lockdown for exams. So that's the college requirement. And they don't take into account additional resources like a SQL developer query environment. So before I move on, and we're going to come back to this, any questions about the midterm, just general questions? Nope. So you're not all supposed to look like this, right? There has to be a couple of smiles out there, maybe. All right. So you can save your questions if you want to ask them. What I would recommend, I'll say this before I move on, the study guide is very helpful. I did actually go through the midterm and ensure that if you've done pretty well in all of your quizzes and you go through the assignments, you won't have a problem or too much of a problem, relatively speaking, with the midterm. So it's 50 questions, 50 points. Yes, go ahead, Suhasini.
I have a question. After the document which you have given for the midterm, if I go through only that document, will I be able to do the midterm exam? Is that just enough?
Yes, that guide, that midterm guide, has basically all of the high-level topics or main topics that are covered in the exam. So yes.
So I need not to go back each and every module and do that if I go through that document.
That's correct.
Thank you.
All right, good question. All right, so let me move on. Now, I'm gonna have to have you take a little bit of a break from worrying about the midterm. But I'm gonna loop back to that after I finish Module 10. Module 10 does have its requirements. So what I would suggest, you can review this lecture material after you complete your refresher. I would not cram. It's not good to cram for the midterm. And then you get the midterm out of the way as early as possible, and then you can, get to your requirements for Module 10 afterwards. So, all right. So Module 10 is subqueries. Subqueries are just that. The topic 1 in Module 10 is the fundamentals of subqueries, and we're going to define and explain the purpose. And for retrieving data using subqueries, we're going to construct and execute a single rule. subquery in the where clause and distinguish between single row and multiple row subqueries or multi-row subqueries. And you'll see what I mean once we go into our little examples. All right, our purpose. I always have to know why we have to do this. Has a friend asked you to go to the movies, but before you could answer yes or no, you first had to check with your parents, although we're mostly adults, and I guess this was written for high schoolers. But anyway, someone asked you to answer to ask you to answer to a math problem, but before you can give them an answer, you had to do the problem yourself. Yeah, I've done that teaching programming. Asking parents or doing the math problem are examples of subqueries. So basically, the answer to the outer query or the main query is dependent upon the inner query or something that's required before you completely provide an answer. So in SQL, subqueries enable us to find the information we need so that we can get the information we want. Now I guess that's an easy way to state that. Find the information we need so we can get the information. So you're basically using it to find something that you can use to do something else. So whatever way you phrase it, that's essentially, it's a dependent relationship. You want to think of it that way. So subquery executes to find the information you don't know. All right. So the outer query uses the information to find out what you need to know. So here's this don't know, need to know, all these. I apologize if this seems like I'm going around in circles, but to understand the relationships between your main query or your outer query and your inner query is important. So being able to combine two queries into one can be very useful when you need to select rows from a table with the condition that depends on the data in the table itself. So yeah, I guess the best way to begin to think about this, you have something that you're trying to figure out, but you have some unknowns or a unknown. All right. So subquery is a select statement that is embedded in a clause of another select statement. So when I say embedded, and you'll see. So subquery executes once before the main query. The result of the subquery is used by the main or outer query. So that terminology, please be cognizant of. The main query is usually the query that is dependent upon the first query or inner query. Subqueries can be placed in a number of SQL clauses, including the where, the having, and the from clause. So it is useful. I've actually used subqueries more than I've used joins for a particular reason. So here's the syntax. So you see this, select your select list or your, either your star or your column names from your table where the expression, so some type of expression operator. So it may be some particular field is equal to or greater than or whatever. And then you actually add another select query in your where clause. And it's actually a true query. And I will say this many times, but the best way to ensure that your query, your subquery or your whole query will run is to just simply highlight the subquery in your developer and make sure it runs and produces a result. And remember, the subquery is always surrounded by parentheses in our syntax. But I've discovered, even in my DBA days, I always make sure the inner query runs before I try to run the whole query itself. Hopefully that makes sense to everyone. All right. All right. So it's enclosed in parentheses. It's placed on the right side of the comparison condition. So if you have a field that's equal to, then it's on the right side of your operator, always. The outer and inner queries can get data from different tables. So, and this is essentially where I've used it, versus a join in certain scenarios. So only one order by clause can be used for a select statement. If used, it must be in the last clause in the outer query. So the outer, so you can't have order by in the inner query. So subquery cannot have its own order by. Remember that. That's one of the general rules of subquery. The only limit on the number of subqueries is the buffer size. So we always throw this in because there's certain buffers, memory buffers, that create limitations, but with the new Oracle developer and all that, you can have nested subqueries and so on and so forth. And we're going to talk about correlated subqueries later. But it's all about common sense, once again, when you're running these queries, because if you can't understand what you're trying to accomplish with the query, then it's probably not useful to have several, layers of subqueries. But yeah, the buffer size is limiting, and that's memory. But I mean, we're all running several gigabytes of memory, and then you have memory management, et cetera, et cetera. I'm not going to get into that, but there's not a lot of limiting, factors in our current computing stage. So not like it was in my lifetime. I can remember when, 25 years ago, we could only have 4 nested types of functions, and then we would run out of buffer size. But anyway, I digress. So I probably don't want to know that, but yeah, I do remember when there was quite a bit of limiting as far as subqueries. Okay. So there's 2 types of subqueries. There's a single row subquery that uses single row operators, and that's greater than equal to, less, greater than or equal to, less than, not equal to, which is, that's really not used anymore. I'll have to change that, or less than or equal to. And return only one row, remember this, one row from the inner query, hence the name single row. All right, and then there's multiple rows or multi-row subqueries that use multiple row operators in, any, all, and they return more than one row. So just remember single row and multi-row or multiple row. Yeah, just the single row operators are pretty straightforward. The in, any, and all, and we'll have examples of that, and it'll make sense once you see those particular examples. All right. So what if you wanted to find out the names of the employees that were hired after Peter Vargas in our little database? The first thing you need to know is the answer to the question, when was Peter Vargas hired? Once you know this hire date, then you can select those employees whose hire dates are after his. Pretty straightforward. That's another, you don't know Peter's hire date, so you use a select statement to find that, and then you can use your whatever your single row operator to find out, or depending on what your results are, the answer to your, essentially to your request, excuse me. There you go. Select first name, last name, hire date from employees where hire date is greater than, and what we're doing here is selecting hire date from employees where last name is equal to Vargas. That's Peter Vargas. So this is going to return one value, right? One date. And this is just saying that the hire date is going to be greater than that date. Does that make sense to everyone? You see that correlation? And hence the syntax of the subquery is the key here. So within your where clause, and this is a single row, that greater than, because we're going to get a single value out of this. Does that make sense? So this is going to be one date, right? Okay, and we'll get, these individuals that have a hire date greater than Mr. Vargas there. All right. All right, so and that's kind of the gist of how the single row subquery works. Very useful, because you would have to query the database to get that date and then plug that date into the select query manually, and you don't have to do that. So if the subquery returns a null value or no rows, the outer query takes the result of subquery null and uses this result in this where clause, which means the outer query will then return no rows, because comparing any value with null always yields a null. So once again, this is an example where you want to check to see if that inner query returns a value. Because if you get no data found, that's really not that helpful. But if you check this inner query and it returns nothing or 0 or null, and remember those aren't the same. If it returns no data, I should say, then your entire query will not find anything. And that's usually a trip-up point. So once again, what I suggest, make sure if you're looking for a particular value, especially in a single row query, you receive a result. So it's not that much difficult to run that inner query. It makes a big difference, saves you tons of time. All right. And that, in a nutshell, is kind of the foundation of a subquery. So our terminology for topic 1, subquery, inner query, outer query, single row, and multi-row subqueries. Pretty straightforward. Any questions about that before we push ahead? Oops. Okay. All right. Let me move on. All right. On to, that's our summary. On to topic 2. And we're going to extract or extrapolate or expand single row subqueries so we get a kind of a broader or at least a more detailed look at how these can be useful. So these are our objectives: construct and execute with where clause or having clause, construct and execute select statement using more than one subquery, construct and execute a select statement using proof functions in a subquery. Yes, you can use proof functions. Excuse me. So as you probably realize, subqueries are a lot like internet search engines, I suppose. They're great at locating the information needed to accomplish another task. So in this lesson, we learn how to create even more complicated tasks for subqueries to do for you. Keep in mind that subqueries save time. Yeah, they do. And that you can accomplish 2 tasks in one statement. All right. Facts about single row subqueries. What do? They return only one row, hence single row. Remember that I don't know, for some reason that creates some confusion, but it's going to return one row. But as you saw in that example before, well, the entire query returned more than one row, but the subquery itself returned that higher date. Remember that. That's what we consider one row. All right, so please make sure you can wrap your head around that concept. All right, so use single row comparison operators, equal, greater than, etc. Always include the subquery in parentheses, place the subquery to the right-hand side of your comparison condition. So always on the right, or after your comparison condition or comparison operator. All right, the outer and inner queries can get different data from different tables, or can get data from different tables. Only one order by, we went over this. And yes, they're limited to the buffer size. But as I said before, that's not really a big deal. But once again, use your common sense, because you should all know there's several ways to perform all of these queries. So maybe a subquery may not even be a more efficient way to do that, perform any particular type of inquiry for your query. All right, so the outer and inner queries can get from different tables. So our question is, who works in the marketing department? If you take a look at this query, select last name, job ID, department ID from employees, where department ID is equal to, so we don't necessarily know what the marketing department ID is, but we know the word marketing. So we just write a subquery, select department ID from departments, right? That's a different table than employees, where department name is equal to marketing. And so from the subquery, you see the result is that now the department ID is 20. That's the marketing department. Yes, it's Hartstein and Fahey. Hey, just figured it out without knowing the department ID. So the unknown in this query was the department ID, but we did know that it's the marketing department. We know that we know the reason why we ran it that way. We know that the department name is not a part of the employees table, but the department ID is. So that's the key there. All right. All right, so subqueries from different tables, so more than one subquery can return information to the outer query. So this one is pretty interesting. So select last name, job ID, select salary, department ID from employees, where job ID is, so we're looking for everyone that has the same job as this particular employee, 141. So we don't know the job ID, but we know we're looking for everyone that is. So we want everyone that's like this employee. And we know the department number is 1500, so whichever department that is. So you see here, select department ID from departments where location, or the location of the department, not the department ID. So we know that the job ID is a store clerk or a stock clerk or whatever you want to, identify this particular job ID as. So everyone that returned should be an ST clerk, and you see they are. And all we know for the example, we know that the department location in your departments table. So we're pulling the department ID so that we know we're trying to find everyone that works on that job in that particular department. So, and what I'm illustrating here is that, yes, you can use several subqueries. And this is just using aware and your comparison. And each of these are returning a single role. So this is returning ST clerk, and this is returning 50. Right? And we get that result. Nice and clean. All right, so group functions, yes, you can run group functions in subqueries. Group function without a group by clause in subquery returns a single row. So once again, a group function without a group by clause in a subquery returns a single row. That's a little bit different than your regular queries. So the query in the next slide answers the question, which employees earn less than the average salary? So the subquery first finds the average salary. Select the average salary, which is 8775, right? So which employees earn less than that? So select last name salary from employees where salary is less than. So basically, this is a group function, but we know it's going to return a single value because we're just looking at the average. So it's averaging all of the employees in the employee table, right? Comes up with that value, and now we can see all the remaining employees that earn less than that value. Does that make sense? Okay. And so group functions, don't get confused by it, because most of the aggregate functions will return a value that you can compare with your operator single row. Yes, it's a group function, and there's no group by here. So make sure you understand that. So we can use subqueries, they can also be placed in the having clause. Remember, the having clause is similar to the where, except the having clause is used to restrict groups, right? And the where is used to restrict rows or records. And always include a group function such as min, max, or average. Because the having clause always includes a group function, the subquery will nearly always include a group function as well. So, and it really depends upon the scenario, once again, but I think that was some of the issue in our group functions from the last section. Remember, what are you expecting as far as the results, and what are you grouping by? So you have to be very, very careful of that. So our question is, which departments have a lowest salary that is greater than the lowest salary in Department 50? So the first thing you have to find is the minimum salary in Department 50, which is our subquery. Select minimum salary from employees where department ID is 50, and that return is 2,500. So it's a single value. Once again, this is a single rule subquery using a group function. And then we're just selecting the department ID minimum salary from employees, and we're going to group them. So basically, we're going to group them by department ID, but this is, so to answer the question, which departments have a lowest salary that is greater than the lowest salary in the Department 50. So the lowest salary in 50 is 2,500. anything greater than that 2,500, which are all these. And these are the lowest salaries, hence the min. Do we all see that? Minimum salary. And we use the grouping function having minimum salary greater than, but this is still a single row function. All right, just remember that. That's returning a single value. So if you wrote that out and just put 2,500 there, you would get the same result here, right? Okay. All right, so in this lesson, we learned about, how we can use subqueries with where, multiple subqueries, using, comparison functions, and then we learned about using more than one subquery and then group functions. And I always want to make sure that, as long as you understand these are single row subqueries, and that group function, especially those aggregate functions like average, min, they're generally, depending upon your use, going to return one value that you compare. You may receive an error depending upon what you're looking for, and we're going to talk about this a little later. If you're looking for a single row or a single value response, and you for some reason you produce multi-rows, it'll actually produce an error, but we will talk about that later. All right, on to topic 3. Now we're going to get into multiple row subqueries. You're probably asking, I don't know, I'm still trying to understand the single row, but it's not too bad. So our objectives correctly use the comparison operators in. Remember that in, you got a little group of things. Any, that's a little bit different than all. I will demonstrate those or show you those here in a second. Construct and execute a multiple row subquery in the where clause or having clause. Describe what happens if a multi-row subquery returns a null value. And it's a very interesting result. Understand when multi-row subqueries should be used, when it is safe to use a single row subquery. I'll tell you right now that if you can use a single row subquery, it lessens the amount of confusion about expected results. Multi-row subqueries can drive you nuts. So you can pare down, and we're going to talk about that because we're going to distinguish between pairwise and unpairwise. And I will illustrate what that means. And then there's these operators exist and not exist. And you can use these to test for return rows from subquery. I'll be frank again. To be frank, I mean, exist and not exist are useful, but the best way to ensure you can predict or expect or just know what your value is from that subquery is just to run it. It's easy to do. In our developer, you just have to highlight it. You can highlight it. You can write the whole query to just highlight the subquery and run it. And that'll actually tell you one way or another. To me, it's simpler. We'll talk about exist and not exist here in a second. So subquery is designed to find information you don't know. So yeah, we know that. However, single row subqueries can return only one row. So what if you need to find information based on several rows and several values? That's the whole idea. The subquery, you will need to return several rows, hence the multi-row. We achieve this by using that and using any of the 3 comparison operators in, any, and all. And we haven't used the any and all, I don't think, before. We've used the in, or have we? Have we used the any and all? Maybe we have. No, I don't know if I may introduce you to them. It's very, very similar to the in, but we'll see here in a second. All right. So whose salary, here's our question, whose salary is equal to the salary of an employee in Department 20? So, well, that's very general and broad. So this example returns an error because more than one employee exists in Department 20. The subquery returns multiple rows. So if we ran this, select first name, last name from employees where salary is equal to, and so we got 2 employees in Department 20, so that's called a multi-row, and you'll get this error. Single row subquery returns more than one row. and it won't run, and you'll be like, what? Well, I don't know why. Well, if you read through that, and if we don't know that there's multiple employees, and well, we do, but let's suppose we don't know. But whenever you get this error, it's just saying that there's more than one result from this subquery. That's all it's saying. It's a single row subquery, not. So what we need to do, the problem is the equal sign. So equal is a single row operator, correct? So how can one value be equal to or not equal to more than one value at a time? And yes, it's silly. It's a very silly question, blah, blah, blah. We know that. So the solution to that is to use these multi-row or operators that we know that we can handle more than one return. So subqueries that return more than one value are called multi-row queries or multiple row subqueries. Because we cannot use a single row comparison, we have to use the multi-row operators in any all. Not operator can be used with any of these three operators. So not in, not any, not all. But once again, common sense and understanding exactly what you're trying to accomplish. And you do have, I do want to mention, you do have the tools to, and it's okay to run queries that don't run. I mean, that don't produce a result. I mean, hopefully you're doing this and just going back and correcting your mistakes or reading the error messages. That's one of the best ways to learn how to create the result that matches your expectation. Ooh, it took me a long time to say that. Anyway, all right, let's talk about these operators for multi-row. The in operators use with the outer query where clause to select only those rows which are in the list of values returned from the inner query. For example, we're interested in all the employees that were hired the same year as employees in Department 90. So select last name, hire date. Employees from employees where extract, and remember that extract function, hopefully. We're just pulling out the year, right? Yeah, don't let that. We're just looking at the year, is in, and then we're using a subquery. Ooh, this is very complicated. So this is a function here. This is a subquery. Select extract year from hire date. Remember, all that's doing is pulling out the year from employees where department ID is equal to 90. So we're looking at for all, so it's going to produce several or a multi-row result, and I didn't put the subquery results in there, but it will show 87, 89, or 93. So that's going to return all employees that were hired in those years. So remember, the in is a list, and this will separate it and make sure it looks like a list, and it follows that in command because it is expecting multiple values within the parentheses, just like any other in query. And so just to review, remember when you can extract a particular part of the date as long as it's a valid date, and it will use that to create the format for the multi-row return. Does that make sense? Okay. All right. All right. Now, any is used when we want the outer query where clause to select rows which match the criteria, kind of like less than, greater than, equal of at least one value. At least is the opportune one value in the subquery result set. So any, at least one, the example shown return any employee whose year hired is less than, or at least 1 year hired of employees in Department 90. So, and here's the subquery. This is this multi-row subquery result. That's what actually that should be on the other query as well. So we know that that's the subquery result, 87, 89, and 93. So we want to use the any, select last name, hire date from employees, where extract year. Once again, is less than any of the, so, which is kind of odd, because if it's less than 93, less than 87, then it's going to be less than not. It's one of those scenarios where, you would wonder, why would you use any here? But any employee that's less than any 3 of those years, any one of the 3 years will be returned as a result set. So, and this one, I know this can be a little confusing because it's a little bit different than the other result set. We want the condition, remember that less than is a single row, but we're using the multi-row operator any. Does that make sense? I was a little bit confused by that when I first read it. And you notice that in the other query there was a 93, but 93 is not less than 93. So that's why that's not appearing in this list. Does that make sense to everyone? Sort of. And that's the any. So it's less than any. Okay. Yeah, any can be confusing. I would make sure to run a few of those queries to make sure you know what the expected results are. We know that the subquery is going to produce this. So then that's where you want to kind of separate the two, make sure you can wrap your head around how is this result being compared, with the any, right? Now the all is another confusing one, which I know I never use this. The all operators is used, we want the outer query where clause to select the rows which match the criteria less than greater than equal to of all of the values. So in the subquery, so the operator compares the values to every value returned by the inner query. So as no employees were hired before 87, so this is why we get no rows returned or no data. So it's going to compare to all of these, and it has to match all. It's such like the all. It's like the or and, but a little bit different. And hopefully, I'm not confusing you. Or whenever you use the all, the condition for a result is that it has to match all of the every single. So there's 93, 89, yes, but 87, no. So if you use a truth table in this, so if you had data and you were matching a particular, I don't know all the names, but if you're looking for someone named John Smith, so you would put first name equal John, last name equal Smith, that and operator, so you would get no results because there's no John Smith in the database. So it's like that. It basically has to match all the values. Now, why would you use that? You certainly wouldn't use that in this scenario because it would only just confuse you. But remember, it has to match all the returns, all the values returned, or else you get no results. And that can be a little confusing, but once again, I suggest just running through those queries that are in the practice query, and I would just read through the query. I always suggest this, run the subquery so you understand results from the subquery, and then do a prediction, your own prediction. What is the result going to be? And once you're comfortable with that, you will have subqueries down. Choose my pencil. All right. Null values are always a challenge, but you always really, essentially, you want to address, well, even in a multi-row query scenario. So suppose that one of the values returned by the multi-row subquery is null, but other values are not. If n or any are used, the outer query will return results. Because basically you'll match the non-null values, and this is the key. So if you run this query here, select last name, employee ID from employees, where employee ID is n, and basically we're trying to get a list of managers. select manager ID from employees. So this is the subquery, right? And essentially, and there's more. It's going to ignore the nulls and just return, which is what you want. So that kind of makes sense. To return all of the individuals that are actually managers. Right? That would be the question to be answered there. And that's using the in or any. So there's an in. But if you use the all will give you problems, because remember the all is saying that your subquery or your outer query has to match all of the values that are returned in the inner query. So just a suggestion, if you're using all, then you're probably pretty sure that you're not going to run into any, well, it definitely won't have any nulls, because nulls never match anything, right? So if we run that same query using all in any condition, it'll always return no data, because nothing will match the null. Not even null matches null. Well, I hope you understand that. And that's why you get no results found or no data found. Because the all has to match every single, once again, I know I'm regurgitating and reiterating, but that's always, all is always very confusing. Any questions about that? All right. Okay, group by and having. As you might suspect, the group by clause and the having clause can be used with multi-row subqueries. So what if you wanted to find the departments whose minimum salary is less than the salary of any employee who works in department 10 or 20? So this is, I think I run the query. All right. So we need a multi-row subquery which returns the salaries for employees in department 10 and 20. Right. The outer query will use a group function, a min function, so we need to group the outer query by department ID. So the query would look, so take a look at this query. Select department ID, minimum salary from employees, group by department ID, having minimum salary less than any, and select salary from employees where department ID is in. So we want 10 or 20, and order by department ID. So that will produce, well, the subquery will produce these salaries here, correct? Select salary from employees where department ID is in 10 or 20. And we're using any. So from the outer query, so if it's less than any of these, 4,400, 13,000, 6,000, and these are all less than any of those. You say, well, 4,400 is equal. Yeah, it's equal, but it's less than the other two. So this is the any. So any salary will match that condition. Sometimes these can be a little confusing, but if you really read through that, the result makes sense. Sorry. Questions about that? This is the result of the whole query. This is the result of the inner query over here. I tried to illustrate that. So if we ran this select salary from employees where department ID in 10 or 20, order by department ID. So, and yep. Remember, this is just selecting department ID from employees, and it's grouping by department ID, having the minimum salary less than any of those. So that's why you have several departments. Now, why would you want to run that and then have to explain that to your supervisor? Yeah. You can probably do that a couple different ways, but that's maybe it's just a SQL challenge, but that's what that does. But the whole purpose is that you see the group by and having, you have having here, you have group by having. You can organize it in a way that makes most sense. and then we're ordering. I mean, the order by is a part of the outer query, not a part of the inner query. I did want to point that out too. The inner query is just what's highlighted here. Okay, and that's producing this simple result, multi-row result. All right. All right, multi-column subqueries. Yes, you can actually create a subquery with multi-columns. We've been doing only single columns, but so subqueries can use one or more columns. If they use more than one column, they're called multi-column. Multi-column subqueries can be either pairwise comparison or non-pairwise comparison. And in a nutshell, before I get into this, pairwise means that basically you're pairing the columns in the inner query with the columns in the outer query, so you're not confusing yourself too much. So we're pairing manager ID with manager ID, department ID with department ID. That's generally referred to as a pairwise comparison. It's just the terminology of query. So in this query, we're essentially selecting the employer ID, manager ID, department ID, where the manager ID and department ID is in, select manager ID, department ID, pairwise, from employees where the employee ID is in 149, 174. And employee ID is not in 148. Now, does this make sense? I keep reading to this query. Why would you actually run something like this? It's just the functional result, just to make sure we know that it's in our manager ID, department ID is in this query, but we don't want the result to be in 148 or 174. What question are we? Well, I guess what I'm trying to illustrate here is the whole idea of pairwise, manager ID, department ID, from your outer to your inner query, you're pairing columns. All right. So this example shows that the multiple column pairwise subquery with a subquery highlighted in red and results in the table and the results in the table of the query list employees whose manager and departments are the same as the manager and department of employees 149 or 174. All right. And it's pairwise because these values are compared with the manager ID column and the department ID column of each row in the employees table. Manager ID. Well, but we don't want the employee IDs from departments or the employee IDs, 148 or 147 displayed. So we don't want the managers of those two employees, but we do want the managers of, although we have 174 twice, which is interesting. I forget why I did that. But you notice the employee ID 174 is not here, but we have 149, 176. Wow. So first, the subquery retrieves the manager ID, department ID of values for employees 149, 174. These values are compared with the manager ID column and the department ID column. Of each row in the employees table. If the values match, the row is displayed. So an output records of the employees with the employee ID 149 and 174. All right. So ultimately, The result of this very confusing subquery is that we don't want 174, but we do want 149. And as far as employee IDs, as far as their manager. So we're trying to see if 149 and 149 is the manager of 176, but the manager of 149 is employee ID 100. Yes, is there a different way to illustrate this? Absolutely. Without doing a subquery, we're not doing something like this. It's the way Oracle says we should train you on this particular scenario. And this is another one where I would review this. I would even review this after the fact and determine there's a simpler way to probably illustrate, who's the manager of whom without going through this. Because this is very confusing. It's in this list, but not in this list. As far as, and these are just employee IDs, so. But that is known as pairwise because we're comparing manager ID and department, manager ID and employee ID to determine, who's the manager of whom in that department. Manager ID, department ID. So our department is 80, that will be returned, et cetera, et cetera. Sorry, I would not believe that. So non-pairwise is a little bit different, but even more confusing. And non-pairwise multiple columns also uses more than one column, but it compares them one at a time. So the comparison takes place in different subqueries. So this pairwise, one subquery, pairwise, non-pairwise that you're comparing the same, but you're using two subqueries. Yes, it's equally as confusing. Non-pairwise, and you're breaking up manager ID and department ID. So this is referred to as non-pairwise. Is any of these useful? It's more confusing than its usefulness. This whole query, I know that this came right out of Oracle Academy, but you can probably think of a simpler way to illustrate this, as I said before. But the whole point is this part of the lesson is speaking to the idea of pairwise, comparing two columns, in one subquery, and non-pairwise, breaking them up into two subqueries and using the AND, using an additional AND. But you see that it's the same query and it produces the same result. Now, your test is to figure out what was the question. All right. And basically, we're wanting to know who the manager is of these two employees, technically, but not, we didn't want to know the manager of 148 or 174, just basically of 149. Anyway, we can go round and round with that. I'll let you all figure that out. I will lessen my attempt to confuse you. The whole purpose of these queries was to introduce the terms pairwise and non-pairwise. And basically non-pairwise is one column per, one query, subquery per column, whereas pairwise is multiple columns in your subquery. That's the biggest difference. Does that make sense, sort of? Right, that's the takeaway. All right, exists and not exist. These are useful. Exists and its opposite, not exist, are two clauses that can be used when testing for matches in subqueries. So exists tests for a true or a matching result. And to answer the question, which employees are not managers, you first have to ask who are managers, and then ask who does not exist in the managers list. Think of it that way. I'm sorry, I shouldn't laugh. So in this example, the subquery is selecting employees that are managers. The autoquery then returns the rows from the employee table that do not exist in the subquery. So take a look at this, select last name as not a manager from employees, and I'm using an alias where not exists. So basically who don't exist in this result. And select star from employees and managers where manager.manager ID is equal. And so basically these are all employees that are not managers. And what was the question? Wait. No, these are all the employees that are managers. To answer the question, which employees? Yeah, these are all the employees that are not managers. And if you look at all of these employee IDs, they're not managing anyone. So you can use the not exist. So it basically will pull out all the employees that don't exist in this table, this result set here. Because these are all managers, right? Does that make sense? That's a little confusing, but we do have a manager ID, and if the manager ID is equal to employee ID, that means that employee is a manager. That's the key here. All right. And you can go back and run that query to make sure. So if the same query is executed with a not in instead of a not exist, the result is very different. Yes. Because that return, it's a multi-row, and I'm just illustrating the example. This is where the not exists is different than the not in. Because this not in is looking for a list that you can essentially compare to every row in the table. So, and that's why, because that's just looking for, a true or not true. All right, so the cause of the strain result is that yes, it basically doesn't essentially work that way. The not in will not look at every single record that's returned in that multi-row subquery to give you a result. This is essentially where the exist, not exist came into play. And it's all about true and false and unknown. This is truly an unknown. All right. So once again, beware of nulls and subqueries when using in or not in. If you're unsure whether or not the subquery, well, so once again, it's always best to run your subquery to ensure that you have values that are returned or result that's returned. So it's either, you want to either use it as not null to differentiate or filter, or not exist. That's the safest way to ensure that you will return data. And that's the usefulness of the exist or not exist in your subquery. Okay, I know that's a lot. All right. One last point about subqueries. Of course, I have to throw one more thing at you. Some subqueries may return a single row or multiple row, depending on the data values in the rows. So if even the slightest possibility exists of returning multiple rows, make sure you write a multiple row subquery. That's just kind of a recommendation. That's why it's best before you even run the entire query, just run the subquery. It will give you a result. So that's, if there's one strong recommendation that I offer to you, that's the best way to ensure that you can take a look and truly, understand what your expectations are as far as the entire query. All right, so who has the same job as Ernst? Single row subquery works correctly because there's only one Ernst. Yeah. So it's basically thinking through what is your expected results. But once again, even if you're looking for a single value, run a single row subquery. If you think you have to compare values or compare lists, then it's usually a multi-row. And that's a general rule of thumb. Either way, once again, I'll say it again, it's best to write your subquery first, or write the entire query, but run your subquery first. That's what I'm recommending. All right. So our terminology exists, not exists, non-pairwise, multiple column subquery, pairwise, multiple column subquery, and multiple row subquery. I forgot to include that, but I wouldn't worry too much about truly understanding non-pairwise and pairwise. Those are like pointers in programming, because it's basically the difference between a multi-column subquery scenario or a single column. That's the biggest difference. And it exists, not exists. Essentially, you can use that, which, I mean, it's almost like running something negative to figure out something positive. So I would say, once again, this is an exercise in just some basic critical thinking problem solving. All right. This is what we learned. Provide a summary. Comparison operators, any, and all, in a multi-row. Construct multi-row subqueries in a where clause or having clause. Describe what happens if a multi-row subquery returns a null value, which is not good. Or with all, understand when multi-row subqueries should be used and when it's safe to use single-row subqueries. It's generally mostly safe to run a subquery as a single row. I guarantee you, a high percentage, I won't say give a number, will definitely work as a single row subquery, because you want that subquery to return a value that you know will be a value that you can use for your outer query. All right. I know, take a deep breath. One last topic, and this isn't too bad, but it's another one of these I haven't, well, in my experience, and it was quite extensive. I haven't used a lot of correlated subqueries, but they can be useful. So that's our last topic, correlated subqueries. So identify when correlated subqueries are needed, construct and execute a correlated subquery. And that's almost like a double entendre, well, correlated sub. Sorry, construct and execute name subqueries with using the with clause. All right. So sometimes you have to answer more than one question in one sentence. I try not to. I try to limit myself to one question per sentence. Your friend might ask you if you have enough money for a cinema ticket or a movie ticket, popcorn and a drink. Before you can answer your friend, you need to know the price of the ticket, the popcorn and a drink. You also need to see how much money you have in your pocket or your wallet. So actually, what seemed like an easy question turns into 4 questions that you need to answer to before you can say yes or no. And you kind of get the gist. This is the whole idea of correlated or related or whatever you want to call them, subquery. So in business, you might get asked to produce a report of all employees earning more than the average salary for their departments. So here you first have to calculate the average salary per department, then compare the salary for each employee to the average salary of that employee's department. All right, the Oracle server performs a correlated subquery when the subquery references a column from a table referred to in the parent statement. So the parent statement is always the highest level. So get candidate row from outer query, execute inner query using candidate row value, use values from inner query to qualify, disqualify. So this is kind of the idea of correlated. This is kind of a circular, process as to how it correlated. And I don't know if that simplifies your understanding, but if you think of this as kind of a running get, execute, use, get, yeah. So a correlated subquery is evaluated once for each row processed by the parent, so processed by the outer or parent statement if it's a single statement. I know that's crisscrossing and mixing languages here, but this whole idea, just keep in mind this kind of whole idea, get, execute, use, get a value, execute whatever, use that value, etc. The parent statement can be select, update, or delete. So let's look at an example. So whose salary is higher than the average salary of their department? To answer this question, we need to write a correlated subquery. The correlated subqueries are used for row by row processing. Remember that, row by row. All right, and if we take a look at this, select first name, old last name, old salary from employees with that alias, where old salary is greater than select, and basically O is outer, I is inner. And yes, we call this a correlated subquery, but it kind of looks like a regular subquery. But the reason why this is correlated, we're going to evaluate, yes, if you're turning multiple rows, but we're evaluating each row to compare it to the salaries from each department, excuse me. So to answer the question, whose salary is higher than the average salary for their department, so we're going to compare that, calculate the average salary, and compare, and just come up with a list of all employees that's higher than the average of their department. So you think this is a single row, it's a single row result, but it's continuing to compare that value coming from the subquery to every value in your table. Does everyone see that? So that's why it's called a correlated, because getting and using, evaluating, using, etc. until you create a result. So it's kind of looping through every time until it completes. We have 20 employees in our employee table, and we come up with 7 that have a higher salary than the average salary of their department. Does that make sense? Okay. That is called a correlated subquery. So execute it for every row. And with the normal subquery, the inner query returns first and execute once, returning values to be used by the auto query. And it goes until it completes all the employees. So in other words, the inner query is driven by the auto query. So the auto query is not going to complete, just like if you had a number in there. But this is calculating the average of each department. So I think most people nodded that does make sense. All right, and that's the only difference between a correlated and a regular subquery. A correlated will continue until all of the records are processed in the table. All right, moving ahead, let's look at the with clause. If you have to write a very complex query with joins and aggregations used many times, you can write the different parts of the statement as query blocks and then use those same. So we're doing a little bit of programming or kind of block programming, query blocks in a select statement. Oracle will allow you to write named subqueries in one single statement as long as you start your statement with the keyword with. The with clause retrieves the results of one or more query blocks and stores those results for the users who runs. So it can become complicated. So the with clause improves performance. It's kind of easier to read. The syntax for the with clause is this with, then you give it a name as subquery as, and then you actually write out your subquery, select column as from table, and subquery name view. It's usually a table, but it can be a subquery or a view where condition is true. And you're like, so you write the query for the following, let's write the query for the following requirement. Display a list of employees' last names that are not managers. To construct this query, you first need to get a list of manager IDs from the employee table, and return the names of employees whose employee ID is not on the manager list. We can create a name query using the with clause to retrieve the manager ID from the employees table. Then the outer query will return the employees that do not appear on that list. So we're just shortening that whole process. So if you do this, and you started with managers as, select distinct manager ID from employees where manager ID is not null, that's going to create a list of managers, right? So in the same query, select last name as not a manager from employees where employee ID not in that little, because that's a subquery. So just using that with clause, it kind of creates this little scenario where, and remember, this is the same list of employees that are not managers. So that's a little simpler to read, because we know that this is basically all the managers, and you can use a not in here because we have a list of managers coming from this subquery. Does that make sense? Another way to do that? It probably the not exist is just as efficient, but suppose you have many subqueries and this is another one of those scenarios, you could probably make it more efficient. But here, by creating this simple subquery, select star from managers, which is this. Now we know that we're going to have a specific list of non-managers. Just another way to perform that specific task that we had before. All right. All right. So that's the width. The width can be useful. You don't necessarily need to use the width in many instances, the width clause in many instances, but it does create some efficiencies, especially get out with large databases. You possibly use that for efficiency. So we learn all about correlated subqueries, how to execute them. Remember, it basically evaluates every row depending on what your auto query is looking for, etc. And executed a name subquery using the with clause or name subqueries. Remember, you can use several subqueries within your little evaluation or executed environment. All right, that's enough to confuse you, right? So that's module 10. Please review that before or after. So before I go on to, well, let me just review quickly module 10. We'll go back to the midterm and field any questions or concerns. All right, so module 10, I will have the lecture up. I'm sorry, I didn't have a chance to get it up. Place it or post it. I will post it very soon after. There's plenty of videos to help you once again, and please evaluate these, make sure they're useful and they're not distracting. There's additional resources for you to understand what the all operator actually does. This one, when I was learning SQL, this one was probably the most confusing, but these little illustrations will make it a little bit easier to understand. And we have for any, and the N is pretty straightforward, but exists, how do you use the exists and where would it help? So please review those. Those actually will help you to understand how those clauses are used. And then your practice queries, once again, a very useful way to understand how these queries work. Usually you write a subquery because you have a kind of an expectation for results, but you have an unknown in there. So those will be very helpful. There are some advanced subqueries in there. They're advanced because you really need to know, they're not essentially what you're trying to accomplish. So I would read through these once you've done the others. Make sure you understand how these, well, we call them advanced. They're really not that advanced, but if you understand what you'd like to accomplish with the results, then these will make sense. There's some correlated subqueries in here. It goes right to the Oracle page. And this offers another very good explanation of correlated subqueries with examples, excuse me, that's tied to our database. So believe it or not. So if you need that, please go through those. It's just a link. It goes right to Oracle Academy. And then your practice. We have 4 topics. for your practice, and that is this week. I know you have a lot to do this week, so this is the week where you really want to not procrastinate, because you have that midterm looming and waiting for you. And then after that, you have all the rest of this. So if you're an overachiever, either you want to tackle some of this before Wednesday, or forget that and say, well, I'll just wait and tackle some of it after I take the midterm. So yes, we do have an assignment for module 10. It's 8 exercises, fundamentals of from the basically fundamentals of subquery, single row and multi-row. I think I took on all that. So that's pretty straightforward. Okay. And then you have a quiz. There's always a quiz. You're like, can you just not give us a quiz? No. Well, sorry about that. So that's it for module 10. So let's loop back, take a few minutes to kind of flush out the midterm a little bit to lessen any angst. A couple reasons, it's a lot to do this week, and I do understand that I'm dumping a lot on you. So I would start definitely with the study guide. If you can print it out, print it out. It's a couple pages. Modules 1 through 9, modules 1, 2, 3, 4, 5, 6, 7, and 9. So it's 8 modules, and all of the material illustrated in the practice guide or study guide will be in the midterm. There's not anything in there that I didn't add anything that should surprise you. At least I thought so. So if there is something, after next week, please let me know, because I've reviewed this a couple times. Make sure you get in. I'm running out of this Respondus lockdown browser testing closes on Wednesday at midnight. I would think that you want to get this out of the way first. I know a couple students have already. It's pretty straightforward, but this is actually due by Wednesday at midnight. Make sure you take care of that. Download the browser, answer the 3 questions. And it kind of gives you a head start in some regards to the midterm. That's kind of a hint. And then the midterm itself, once again, it's 50 questions. It's a 90-minute time limit on it. So here you go. Here's a preview of all the questions. So who wants to pick out a question for us to review? Anyone? Oh, here. Since no one's speaking up, I'm going to take a look at one. Select statements are used for what? This one, changing data in the database, changing table structure, retrieving data from a database. Now, I could have made that clearer, but retrieving data is always a select. So that's number 1. What is the most widely used DBMS? And these are things that I talked about way back in week 1. So who wants to answer that one? What is the most widely used DBMS database management system? What's the most widely used? What are you working on now?
SQL?
No, that's the language. That's SQL query.
Oh, relational database?
Yes. Who said that?
Angie.
Angie, you are correct. It is relational database. And I will show you relational. All right, there you got 2 points. Okay, one more. I'll go further down. All right. So we're looking at this inventory table columns: ID number, description, manufacturer ID, quantity, price, order date. And we run this query: select ID number from inventory where price is in 8.25028 which values would be displayed in the results?
It would it only be the ID number 36023 because because in the list there's no other match. It's just 8.25.
Does everyone see that? Oops, this one. Because there's no 028 in there, right? In the price. Right?
Right.
So it would only return that ID. 36023. All right, see, it's not that bad. We answered 3 questions in about 2 minutes. So you only have 47 more to go. Right? I don't hear anyone cheering. I know
I'm
y'all
cheering.
want me to go through the whole midterm, right? Can we just do it in class? Well, I can't
That
really
would
do
be
that.
nice.
It wouldn't be a midterm then, but yes, it's right. I think I did make it all multiple choice now. I'm pretty sure I did. I don't think there's anything in there that's not multiple choice. No, that one. Oh, this one. All right, which of the following queries? Oh, I can't show you the answer. Let's see. I'm going to preview it. I think it's question 42. Will the following query return one row? It's using those group functions. But what would be the answer? No or yes? Will this query return one row?
Yes, just the
Yes.
maximum and the minimum for all the employees.
It will return the highest salary and lowest salary. What about the average? We have an average salary in there too. I'm going to show you this one. Right? One row, right? Y'all see that? Maximum, minimum, average, which is, you probably want to round that. Let's do this. So that's one row, right? Everyone see that? One row. So that question would be, yes, it will return the highest salary, lowest salary, and the average salary from all employees. Right? The highest salary is 24,000, the lowest is 2,500, the average is 8,895. Yeah, you don't have the developer, but you probably read that query, right? And know that it's going to return one row, yes, but It's not gonna return only the average or only the highest, because we got max, min, etc. All right. Okay, so any general questions about the midterm? I've given you a head start. Was that 4 questions? Is everyone taking notes? I don't remember what question that was. I gave you a chance. So now you only have 46. So, and 90 minutes. Any questions? Is that enough? Yeah. Yes. So Hasani. So let's see. Go ahead. Question? Do you have a question? Oh, let me stop sharing.
Is there any relaxation for module assignment deadline?
Well, we have to kind of keep going forward, but I tell you what, I will see how many of you and what your scores are in the midterm by Thursday. If you're all waiting until Friday, then I'm just going to say, well, because you're all waiting. So I can't really do it relaxing. We'll see. If everyone's struggling with the midterm, I may push it back a couple days. But
Okay, thank you.
but let's just see how you do. I mean, we use the term midterm, and everyone goes, "Oh, that's I'm just not going to do well." So you can't psych yourself out. It's really not that hard if you study, but don't overstudy. Don't try and cram because it won't do you any good. But if you've been doing the exercises all along, all the practice and all that ridiculousness, and your grades have been pretty well, which most of you are, you won't have a problem with the mid. You can probably run through the midterm once and get, 75% of the questions in like 15 minutes. And I'm not exaggerating. They're really that straightforward, quote unquote. And then you can go back to the ones you have to think about, and you have 65 or 75 minutes, right? Every hour. So that's what I would suggest. Go through all the questions that you can answer right away, get them out of the way. Don't close it, don't submit it. Then go back and answer the ones that you haven't. You can take 3 or 4 minutes on those. Okay.
Regarding module assignment dates, I'm worried. Module 10 assignment.
Right. Module 10 is due on Sunday, but like I said, I'll be a little bit lenient, but I'm gonna kind of gauge if you're all gonna be like, I'm not gonna. I will be lenient, so I'm not gonna give you a 0 if you're late. I'll tell you that. I mean, and I'll even go in and expand the. I'll put a due date still Sunday, but I'll keep it open until like Wednesday. How's that? Is that fair enough? See there.
Yeah, great. Thank you.
I'll do that. So I'll do that right now because I can feel that you're all concerned. So I'm going to go in here. You're like, how can you do this to us? Well, I'm a hard nose. I know, but I'll do that. So I'll keep them open until Wednesday. So it'll show late, but I won't deduct any late points or anything like that. See, I'm doing this right now. 26. Oh, wait. Wednesday is April 2nd already. Wow. All right. So both will remain open until Wednesday. So take care of the midterm, and then you can worry about module 10. Because I'm real. I should maintain my hard nosed tough professor. Nah, I can't. All right. So there you go. Open until Wednesday. Okay. Is that fair enough? Is everyone happy with that? All right. All right, so take care of that. And once again, don't wait until, remember the midterm closes at midnight on Friday. So I would not wait until Friday. And then you're gonna be in panic mode and you're gonna get half the questions wrong. Just because you're panicking and you're not reading, and you'll be done in like 45 minutes and you'll realize, wait, geez, I had 45 minutes to go. So just take a deep breath and just go through each question. 2 minutes is actually a pretty long time. But yeah. All right. Okay, so it's a busy week and I'm trying to. Now, if everyone fails the midterm, well, I don't know. Then I'll just have to go back to strict learning and cracking the whip and all that. So we'll see. All right, any other concerns or questions? No. Let me just do a last check on attendance. Is Mackenzie here? No. Is Jeff? No. Ethan? No. Okay. Well, with that, remember, don't panic. And it doesn't open until Wednesday, so just relax, do your meditation, watch, some crazy TV or something. And then 8:01, get in there and get it out of the way. That's what I suggest. All right. Okay. All right. I will see you all then next week. If you're having any issues after the midterm, I'm not going to come in, and I already answered 4 questions for you, so I'm not going to do any more. But make sure you take care of Module 10 before Wednesday. Okay. And then we go on to module, I think we have 2 modules next week, so there's no slacking off anymore. So it's going to be. All right. All right. Thank you all. I will see you all next week.
Thank you.
Thank you.
Thank you.
Thank you.